Today we are going to discuss reactions of amines. Second reaction is alkylation that we have discussed already in haloalkane chapter. Now come to the reaction of acylation. So let's read from the book. Aliphatic and aromatic primary and secondary amines react with acid chloride, anhydride and ether by nucleophilic substitution reaction. This reaction is known as acylation. You can consider this reaction as the replacement of hydrogen atom of NH2 or NH group by acyl group. The product obtained by acylation reaction is known as amides. The reaction is carried out in presence of base stronger than amines like pyridine, which removes HCl so formed. Shift the equilibrium to the right hand side. Now let's see the reaction. So let's take the example of ethane amine. In ethane amine there are two carbon atoms. So C2H5 and here it is bonded with NH2. Nitrogen has one lone pair of electron. So it can act as a nucleophile when it reacts with acid chloride. So here this is C double bond O Cl and on the other side it is bonded with CH3. So as this carbonyl carbon is electron deficient carbon, so this carbonyl carbon will act as an electrophile. So it will undergo nucleophilic substitution reaction. Alkylamine attack on carbonyl carbon by the lone pairs of nitrogen. And here you will get the product. In this product C2H5 group is there and this nitrogen is bonded with two other hydrogens and now it has made bond with the carbonyl carbon. To make bond with the nitrogen, this pi bond move to oxygen. So here you will get oxygen. Now this oxygen will develop negative charge. And the nitrogen, as it is donated lone pair to carbon, this nitrogen will develop positive charge. Here it is bonded with CH3 and on this side it is bonded with Cl. Now to neutralize the charge over nitrogen, this hydrogen leaves the molecule without its bonding pair of electron. So here you will get C2H5. Now this nitrogen is bonded with one of the hydrogen and it has made bond with the carbon. Here this is oxygen which has negative charge. Here it is bonded with Cl and here it is bonded with CH3. Now this negative charge move back between carbon and oxygen and expel Cl in the form of Cl negative ion. So here you will get the product. This is C2H5. Here it is bonded with nitrogen. Nitrogen is bonded with hydrogen. This is carbon. Now double bond is formed between carbon and oxygen and here it is bonded with CH3. And Cl left the molecule in the form of Cl negative ion. In the another step we have already removed hydrogen in the form of H plus ion. So that H plus will get combined with Cl and form HCl. And this HCl is removed with the reaction of pyridine. That's how it shifts the equilibrium to the right hand side. Means the formation of amide is favored. Now write the name of this amide. In this amide there is ethyl group bonded to nitrogen and this amide has contained two carbons. So the parent name will be ethane amide. And ethyl group is bonded to nitrogen, so the name will be N-ethyl. And as this amide contains two carbon, parent name will be ethane amide. Now let's read from the book. In ethane amide, this nitrogen is bonded with one alkyl group, so this is primary amine. Now come to the next example. Here this nitrogen is bonded with two other alkyl groups. So this amine is secondary amine. and the name of this amine is N-ethyl ethane amine. When it reacts with acid chloride in presence of base, this nitrogen will attack on the carbonyl carbon and double bond move to the oxygen. So let's try to write the reaction. So here there is C2H5. Here it is bonded with nitrogen. There is another C2H5. Here this nitrogen is bonded with hydrogen, and this nitrogen has a lone pair of electron when it reacts with acid chloride. So here this is CH3 C double bond O Cl. So it will attack on the carbonyl carbon, pi bond move to oxygen. So here you will get C2H5 nitrogen. Here it is bonded with hydrogen. On the other side it is bonded with another ethyl group. Now this nitrogen will develop positive charge. Now it will make bond with the carbonyl carbon. Here it is bonded with CH3. On the other side it is bonded with Cl, and this is oxygen which develops negative charge. Now in the next step, this hydrogen leaves the molecule without its bonding pair of electron. This negative charge moves back between carbon and oxygen and expels Cl in the form of Cl negative ion. So here you will get C2H5. Here it is bonded with nitrogen. On the other side also ethyl group is there. Now charge over nitrogen is neutralized. This is carbon. Here it has made double bond with the oxygen, and as Cl left the molecule in the form of Cl negative ion, here it will get attached with CH3. In the same step, H plus is removed and Cl is removed in the form of Cl negative ion. So here you will get HCl. Now write the name of this amide. In this amide there are two ethyl groups bonded with nitrogen. So the name of this molecule will be N-diethyl, and as the amide contains two carbon, so the name will be ethane amide. Now come to the next example. In the next example there is phenyl group bonded to nitrogen. So again this is primary amine, and the name of this molecule is benzamine. When benzamine react with ethanoic anhydride, aromatic amines can also react with acid chloride, but in this example they have taken the example of anhydride. So when it react with anhydride, in the similar way nitrogen attack on the carbonyl carbon by the lone pair of its electron. Now this pi bond move to oxygen. So let's write the reaction between benzamine and ethanoic anhydride. So here it is C6H5, and here it is bonded with NH2. Nitrogen has lone pair of electron. When it react with ethanoic anhydride, means anhydride formed by the ethanoic acid. So here O, C double bond O, CH3. So it will attack on the carbonyl carbon, and now pi bond move to oxygen. So here you will get the product. In this product, this is C6H5 nitrogen. Here it is bonded with hydrogen. On the other side it is also bonded with hydrogen. As this nitrogen donated lone pair, it will develop positive charge. Now here it is bonded with carbon, single bond oxygen. One side it is bonded with CH3, on the other side it is bonded with O, COCH3. This oxygen develops negative charge. To neutralize the charge over nitrogen and over oxygen, this hydrogen leaves the molecule without its bonding pair of electron. This negative charge moves back between carbon and oxygen and expel acetate ion. So here you will get C6H5N. Here it is bonded with hydrogen, and here you will get carbon double bond oxygen. On the other side it is bonded with CH3. And here you will get O, single bond C, double bond O, CH3, negative charge over it. This is CH3CO O negative acetate ion, and here this is H plus is removed. So here you will get acetic acid as a byproduct, and this acetic acid is neutralized by the base. Now write the name of this amide. In this amide, phenyl group is bonded to nitrogen, and this amide contains 2 carbon. So the parent will be ethane amide, and phenyl group is bonded to nitrogen. So here we will write N-phenyl ethane amide. Now let's read from the book. Amines also react with benzoyl chloride, and this reaction is known as benzoylation. This is the example of methane amine react with benzoyl chloride. Here you will get N-methyl benzamide. So let's try to write the reaction between methane amine and benzoyl chloride. So this is CH3, nitrogen is bonded with another 2 hydrogens. Nitrogen has lone pair of electrons. When it reacts with benzoyl chloride, means C6H5, C double bond O, Cl. So it will attack on carbonyl carbon, pi bond move to oxygen. So here you will get the product CH3, nitrogen is bonded with 2 hydrogen, and as it has donated lone pair, it will develop positive charge. Now it will make bond with the carbon. Oxygen, it will develop negative charge as the pi bond move to oxygen, and this carbonyl carbon is bonded with C6H5, and on the other side it is bonded with Cl. Now to neutralize the charge over nitrogen, this hydrogen move without its bonding pair of electron. Negative charge move back between carbon and oxygen and expel Cl in the form of Cl negative ion. So here you will get the product. This is CH3. Here nitrogen is bonded with 1 hydrogen, and this is carbon. Now double bond is formed between carbon and oxygen, and this carbonyl carbon is bonded with C6H5. Now write the name of this amide. In this amide, methyl group is bonded to nitrogen. So the name of this amide will be N-methyl, and this amide is benzamide. So you will write benzamide. So the name of the product will be N-methyl benzamide, and this reaction is benzoylation. Now let's read from the book. What do you think is the product of reaction of amines with carboxylic acid? They form salt with amine at room temperature. Amines are base and carboxylic acids are acid. So that's why they form salt with amines. Now let's write the reaction with carboxylic acid and amines. This is R, C double bond O, OH. This is carboxylic acid. When it reacts with amine, amine is R, NH2. I have taken the example of primary amine. So as I told you, carboxylic acid is an acid and amine is a base. Nitrogen has lone pair of electrons. Carboxylic acid donate H plus to the amines. So here you will get R, C double bond O, O negative. This is carboxylate ion, and as the amine accept H plus from the carboxylic acid, it will form R, NH3. Now nitrogen develop positive charge. So this negative and positive, they get combined together and form salt. Now let's read from the book. Next reaction is carbylamine reaction. Aliphatic and aromatic amines on heating with chloroform and ethanoyl potassium hydroxide forms isocyanide or carbylamines, which are foul smelling substances. Secondary and tertiary amines do not show this reaction. So this reaction is not shown by secondary and tertiary amines. This reaction is known as carbylamine reaction or isocyanide test, which is used to test primary amines. Now let's see the reaction. This is primary amine. As only one alkyl group is bonded to nitrogen, this is primary amine. When it reacts with chloroform in presence of KOH, on heating, alkyl group will get attached to isocyanide group. So here that's how you will get isocyanide or the carbylamine. HCl and water is removed as a form of byproduct. And this carbylamine is a foul smelling compound. So that's how you can distinguish primary amine from the secondary or tertiary amine. Now come to the next reaction, reaction with nitrous acid. Three classes of amine react differently with nitrous acid. It is prepared in situ from mineral acid and sodium nitride. Means nitrous acid is prepared inside the reaction mixture by the reaction of mineral acid and sodium nitride. In first reaction, primary aliphatic amine when react with nitrous acid to form aliphatic diazonium salt, which being unstable liberate nitrogen gas quantitatively and alcohols. Quantitative evolution of nitrogen is used in estimation of amino acid and proteins. Proteins are also known as polyamides, and in amino acid amino group is there. To estimate nitrogen present in the amino acids or in protein, this reaction can be used. In this reaction, when primary amine react with nitrous acid, this nitrous acid is prepared in situ by the reaction of sodium nitride with HCl. It gives diazonium salt. So let's try to understand the meaning of diazonium. This is diazonium. Di means two, azo means nitrogen, and ium is used for positive ion. In diazonium there are two nitrogen which carries positive charge. So here this is R and here N2, and this nitrogen carries positive charge, and here to balance this positive charge Cl negative ion is there. So this is diazonium chloride. When it react with water, means when it undergo hydrolysis. On hydrolysis, nitrogen is removed in the form of N2. So on hydrolysis you will get ROH. N2 is removed in the form of nitrogen gas, and Cl is removed with HCl. So here you will get HCl. So that's how nitrogen is liberated quantitatively, means you can measure how much nitrogen is removed, and you will get alcohol as a byproduct. Now come to the next reaction. Aromatic amine react with nitrous acid at lower temperature to form diazonium salt, a very important class of compound used for the synthesis of variety of aromatic compounds, discussed in section 9.7. So when aniline react with nitrous acid. So this is aromatic amine. Aniline is the example of aromatic amine when it reacts with nitrous acid, which is prepared in situ by the reaction of sodium nitride with HCl. It gives benzene diazonium chloride. This benzene diazonium chloride is very useful compound. It is used for the synthesis of variety of aromatic compounds. Secondary and tertiary amine react with nitrous acid in a different manner, which is not discussed here. Now come to the next reaction, reaction with arylsulphonyl chloride. Benzene sulphonyl chloride, which is also known as Hinsberg reagent. So benzene sulphonyl chloride is known as Hinsberg reagent, reacts with primary and secondary amine to form sulfonamides. So let's see how does it react with primary amine. This is benzene sulphonyl chloride. It is also called as Hinsberg reagent when it reacts with primary amine. This amine is primary amine. Now let's write the reaction with Hinsberg primary amine and Hinsberg reaction. So here this is C6H5, this is benzene sulphonyl chloride, sulfur double bond oxygen, here double bond oxygen, and here it is bonded with Cl. When it reacts with ethanamine, ethanamine is C2H5, here nitrogen is bonded with two other hydrogens, and nitrogen has lone pair of electrons, so it will act as a nucleophile, and here this sulfur will act as an electrophile. So this nitrogen will attack on the sulfur by the lone pair of electrons. Pi bond move to oxygen. So here you will get, this is C6H5 sulfur. Now this oxygen will develop negative charge, and here it is bonded with oxygen, here it is bonded with Cl. Now it has made bond with the nitrogen. Nitrogen already is bonded with two other hydrogens, and on the other side it is bonded with C2H5. Now this nitrogen has developed positive charge. To neutralize the positive charge, hydrogen leaves the molecule without its bonding pair of electron. Now this negative charge moves back between oxygen and sulfur and expels Cl in the form of Cl negative ion. So here you will get the product C6H5, here sulfur. Now double bond is formed between oxygen and sulfur. Here there is double bond oxygen. Now this sulfur has made bond with the nitrogen, which is bonded to one side with hydrogen and on the other side with C2H5. So this is benzenesulphonamide is formed. Now let's write the name. In this molecule, ethyl group is bonded to nitrogen. So first of all we will write N-ethyl, and rest of the molecule is benzenesulphonamide. Let's write, this is benzenesulphonamide. Now let's read from the book. The hydrogen attached to nitrogen in sulfonamide is strongly acidic due to presence of a strong electron withdrawing sulfonyl group. Hence it is soluble in alkali. So let's see here. Here this hydrogen which is bonded to nitrogen. This hydrogen is strongly acidic hydrogen. So let's write, this hydrogen is acidic hydrogen, as it is bonded with electron withdrawing sulfonyl group. This electron withdrawing sulfonyl group withdraw electron density from nitrogen, which ultimately withdraws electron density from the hydrogen, and removal of hydrogen in the form of H plus ion become easier. So that's why this hydrogen is acidic, or as this molecule is acidic in nature, it is soluble in alkali. So that's why this is soluble in alkali. Now come to the next reaction. In the reaction with secondary amines, N-diethyl benzenesulfonamide is formed. Now let's write the reaction with this. When it reacts with secondary amine, one of the hydrogen which is attached to nitrogen will be removed to neutralize the charge over nitrogen. So in the product there will be no hydrogen directly bonded to nitrogen. So what do you think? Will it be soluble in alkali or not? Since N-diethyl benzenesulfonamide doesn't contain any hydrogen atom attached to nitrogen atom, it is not acidic, hence insoluble in alkali. So that's how you can distinguish between primary and secondary amine. When you react primary amine with Hinsberg reagent, you will get amide which is soluble in alkali. But when you react secondary amine with the Hinsberg reagent, you will get the amide which is insoluble in alkali. Now come to the tertiary amine. Tertiary amine do not react with benzenesulphonyl chloride. Now let's try to write the reaction with Hinsberg reagent and tertiary amine. So this is Hinsberg reagent C6H5 S double bond O, here double bond O, and this is Cl. When it react with tertiary amine, so R, N, R, R. This nitrogen has lone pair of electron. So when it try to attack on the sulfur, negative pi bond move to oxygen, and here you will get the product C6H5. It is bonded with oxygen. This oxygen will develop negative charge. Here it is bonded with oxygen. On the other side it is bonded with Cl, and on the other side it will make bond with nitrogen, which is already bonded with three other alkyl groups. this nitrogen will develop positive charge. But to neutralize the charge over nitrogen, there is no hydrogen. So when this negative charge moves back between oxygen and sulfur, it expels this amine group. You will get the reactant back. That's why it is written here, tertiary amines do not react with benzenesulphonyl chloride. This property of amine reacting with benzenesulphonyl chloride in a different manner is used for distinction of primary, secondary and tertiary amine, and also for the separation of mixture of amines. However, these days benzenesulphonyl chloride is replaced by para-toluene sulphonyl chloride. Instead of benzenesulphonyl chloride, you can take para-toluene sulphonyl chloride. So let's try to draw the structure of para-toluene sulphonyl chloride, which is used in place of Hinsberg reagent. So this is benzene. Here sulfur is there, sulphonyl chloride is there, sulfur double bond oxygen. Here on the other side also it is bonded with oxygen, and here Cl group is there, and at para position this is CH3. At para position of toluene, sulphonyl group is there, so the name of this molecule is para-toluene sulphonyl chloride.